When you convert from the vector equation of a straight line to the Cartesian form, you get a huge bunch of fractions over here. But in truth, it's really simple and it's a matter of whether you've done it before. So, in the previous video, we talked about r is equal to a plus lambda b. That's the vector equation of a straight line. So, r is equal to a plus lambda b, where lambda is a real number, not to forget. And we're going to divide all these vectors into their x, y, z components. So for r, it's x, y, z in Cartesian. And we have a1, a2, a3. Now these are just real constant numbers. They're just real numbers, right? For specific a and b position and parallel vectors. Right, so these are the three x, y, z components, and we're going to write three equations along these components. So we have x is equal to a1 plus lambda b1, y is equal to a2 plus lambda b2, and then z is this. Alright, now we're going to make lambda the subject, because that's the only variable that links that links these three equations together. So we have lambda is equal to x minus a1 over b1. And that's equal to y minus a2 over b2, which is equal to z minus a3 over b3. Alright, that's all. That's all you need to know for changing from vector to Cartesian form. So let's try some examples to prove that we know how to do it already. So find the Cartesian equation of the line, this vector equation over here. So we have the a tilde over here and the b tilde over here, right, with lambda as the multiplier. So we have xyz is equal to negative 2, 4, 0 plus lambda times 1, 2, 1. And just like we did just now, we have x is equal to negative 2 plus lambda, y is equal to 4 plus 2 lambda, and z is equal to just lambda. And when we convert all of these into the form of r is equal to 8, we need to convert all of these to the form of the three fractions as shown just now. So we have lambda is equal to, now let's start with x first, you get x plus 2, which is equal to y minus 4 over 2. That's equal to just z. Alright, so this in a sense is your Cartesian equation. It's not in a sense, it is your Cartesian equation. So for the second application question, we have find the vector equation of this Cartesian form over here. So we have lambda is equal to x minus 3 over 2. Right, they always remove the lambda for the final answer. And when you multiply out, you get x is equal to 2 lambda plus 3, y is equal to lambda minus 1, and z is equal to, now this is a little more complicated, but after some factorization, you get 3 lambda minus 1, you get half minus 3 over 2 lambda. Right, you want to change this to the form of r is equal to a plus lambda b, lambda a real number. Right, so you need to get this sort of a vector equation now. You have r is equal to x, y, z. So you just write out whatever you have here first. 2 lambda plus 3, lambda minus 1, half minus 3 over 2 lambda. And you realize that a is without the lambda term and b is all the lambda terms. So you have 3, negative 1 and half. So that settles all the non-lambda terms plus lambda times 2, 1, negative 3 over 2. Alright, of course, at this point in time, lambda still isn't defined because it's still the equation of a line. Anything is possible.